Hello everyone, in this video we will talk about LTCT meters. See the first three, 1, 2 and 3, the first three are LTCT meters and the last one is the Janus whole current meter. All of them are three-phase meters only. See the meter terminals are like this. So in this video we will focus our discussion on the first one, on this Premier Secure meter. This is nothing but an LTCT meter, just like your Inage smart meter and your HPL meters. Okay, the first three are LTCT meters with the almost same voltage rating and current rating. For example, this one is a three-phase 240 volt. This one also three-phase 240 volt, right? Is it? Because these are LTCT meters, so it should be same only. Where is it written? It will be written somewhere. CS is 3 into 240. Same thing here also is 3 into 240. That means all these, even this also, these are LT meters. All right, these are LT meters. And the current rating also, here is dash by 5, here also dash by 5, this one also dash by 5. Okay, 5 is the base current and the maximum current is 10 ampere, twice of IB. All right, and then the accuracy class, out of the three, out of the Secure, this Inage smart meter and this HPL meter, which one is more accurate? I mean, as claimed by the company. We will see the Secure meter, the accuracy class is 0.5s. That means if the percentage error of this as claimed by the company is less than 0.5%, and of this is slightly more, it's 1%, and of HPL it's 0.5, less than 0.5%, because it's class 0.5s. All right, now we will as I said, we will just discuss the first one, because I think in previous videos I've already discussed about the Inage smart meter and this CTSM HPL smart meter. So in this video we will discuss about the Secure meter, this one. Okay, so we will see this is nothing but an LTCT meters with the meter terminals. If I open like this, it will be this one. Okay, you see there, and the detail of the terminals you will see when you open this like this. You will see it's already written there. All right, 1S is there, then R, 1L, 2S, Y, 2L, 3S, B, 3L, and S and L. The meaning of this I think you already know. 1S mean is like S1 and S2. All right, and S means source, and this is load side, or supply side, load side. This also to S mean Y phase S1, to L mean the Y phase S2. Okay, L mean load side, it is supply side. This is how you connect, you do the connection. It becomes simpler when you do this. And just like here, the PT supply to the neutral, it's a separate terminal. Here also you will have a separate terminal there. All right, this is LTCT, it's a separate one. Okay, but this one you can give a PT supply of neutral to either an L or an S according to the circuit diagram given on the meter terminal cover. This every meter you will have the circuit diagram, the standard circuit diagram. So this is the one, right? You can give the PT supply to this one, to NL, the PT supply, then the neutral voltage will be given to NL. You can give to NS also, but this is how the standard looks like, because normally this is what we do. And we will go to this meter. This is the connection. Before the arrival of the smart meter, we were using this meter. They are quite good also. I mean, they normally don't get burned or don't get damaged. But now with the arrival of smart meters, these Inage is a smart meter, this one is also smart meter. These two meters are actually replacing the Secure meter, which is a non-smart in the market, right? But then if you see at the construction point of view, at the robust point of view also, this is more robust because it doesn't get damaged that easily. Not like these two, they get damaged easily, and because of over voltage issues and all that, they get damaged very easily. But this is not the case, because it's very robust, because this one has been running. We will I will connect this to the system. I will connect some load to this, and then we will see how the connection is done also. And as I said, the voltage and current rating is same as that of the smart meter, is dash by 5 and 50 power factor 1 to 5, and then the LED impulse for every unit of active power consumption. The constant here is 8,000. All right, it is half of the two, these thing. I think is 16,000 is the LED impulse. All right, and this one, how much is it? This one is 2,500. This one is even lesser, but this one is 8,000. all right, which is half of this and almost 3 times of this. All right, so the accuracy class I already said is 0.5. and you will see this meter. What does it measures? It is a 3-phase 4-wire. It's understood because you have a neutral also, and the voltage that it gives is 240. So the parameters that this meter gives is your you see there is your kWh. The first one is kWh. all right, is your active power consumption. It will give you active power consumption, reactive power consumption, and the apparent power consumption will also give, and the demand in kW. So you can easily tell that, because for consumers of 50 kilowatt and above, we are billing them on the basis of kVAh, and the demand, the associated demand, will be kVA. So this one doesn't give you the kVA. So for consumers of 50 consumers and above, we normally do not use these meters. We use only for consumers below 50 kilowatt, up to 50 kilowatt, and below 20 kilowatt also we don't use this, because in that case you don't need a 3-phase meter, right? You don't need an LTCT meter. You can use a whole current meter. All right, so a consumer with connected load 30 to 50 kilowatt, we can use this meter. All right, now we will see this meter. What does it give? What are the readings inside? I will just give you the load, and then I'll do the connection. Also, I'll be using single phase, and then based on a single phase supply, I'll convert it to 3-phase, and the connection I will do in such a way that this in the eyes of the meter, even though we have a single phase, it will be like a 3-phase. Okay, this is what we will be doing. So let's go and do the connection. So this is how I have connected. You see the meter I have connected. This is supposed to be the connection is supposed to be connected through the CTs, but then since I do not, I'm using a heater which is 1000 watt or 1 kilowatt heater. In that case, if you calculate, the current will be around 3.98, 3.97 something, 3.98 ampere. And since the base current of this is 0.5, which is more than that 3 point, you can use this. You can simply use a whole current. It will be like whole current. And the connection, since I have only a single phase meter, so I will convert this into 3-phase by looping, from the R phase like this. I loop to, this is S1 of R phase, S2, and then I loop to S1 of Y phase like this, and then I again loop to S1 of B phase like this, and then to the neutral, and then I'm using the same voltage, which is the same voltage to R, Y, and B. The PT supply is same only. So this is in the eyes of the meter, it will be like 3-phase. Okay, the meter will not know whether it is single phase or 3-phase, because I have faked the connection. So I have connected the heater like that. So we will see, I will on this, and then we'll see the reading. What are the readings? Okay, I've used this TTB also, because for simplicity you can do lots of things with the help of TTB. All right, now I will try to on this, and then we'll see the readings. All right, and we'll see the reading. Okay, I'll on this. All right, now the output is available. You can see it's running quite fast because it's 800. In the previous videos, it was 16,000 pulse for every kilowatt hour. So obviously it will be twice of this. The number of blinkings, the frequency of blinkings, twice of this. It was running very fast, but this is slightly half of that only. So see, there is the load. All right, now we will see the reading of this, what it actually gives you. So you see this, the first push button is actually for maximum demand, for resetting. So I have deactivated by putting a seal here, so that you cannot reset the maximum demand. Only the utility or the authorized personnel is allowed to reset this. Okay, but then I will show you that also later. We will first see the readings. So I will first see this screen will come, and the time here today is, the time now is 17:25, and the date is 5 of October 2024. And next is the demand 0.25. all right, now we will see the maximum demand is also not there, because this has not been in use for long time, and 206 abilities are not required. It has been on for this much hours, and this is the cumulative capability. This is what is required, is 25533.4, and this is the reactive power consumption is this much, reactive energy, and this is the kVh, which is 46971.8. all right, and then this is R phase voltage, which is 249 R phase voltage. Pn1 mean R phase voltage, and then Pn2 is Y phase voltage is 250, because I'm using the same voltage, it will be almost same. And this is B phase voltage is 250 volt, and then this is line 1 current, which is 3.9. like I said, it will be less than 5, 3.94 ampere. And line 2 also same, because I have connected in series, 3.94 ampere. And then B phase also, line 3 is B phase current is 3.94 ampere, because they are matching, because I'm using the same current only by looping. And then the power factor, since that the load is a heater, which is not a coil, so the power factor will be 1. all right, and now the present demand, this is the load. The present demand is 2.96, almost 3 kilowatt, because it's a 1 kilowatt heaters for all the 3 phases. You will add it, you will get 2.9, almost 3 kilowatt, which is true. Okay, and then like this, and the kVA in terms of kVA with 2.95, but it gives you the kVA. I thought it's not giving, but it gives actually, which is fine. It can be used for consumers of connected load 50 kilowatt and above also, because you are getting kVA here. all right, now kWh, this is H1, I mean of, for example, now is October, so this is of September is this much. And then the demand of today, this month is October, and the maximum demand of September was 0.65 kW, and the power factor is 0.59. it has been on for 227 hours, so like this. Okay, so this is how you take the reading of this meter. It's quite easy. Phase sequence inverse, in this is the CMD, cumulative maximum demand 162.676. we should not take this for billing purpose. This is just to understand, like if somebody is reset the maximum demand, this is not to be taken for billing purpose, but it has been a mistake, for the utility. Sometimes we take this and the bill shoot up. Okay, so this is how you do. And the advantage of this meter is that even with the absence of neutral voltage, you can still get the you can still on the meter. all right, so this is how the connection of this meter is done. It's just like your present smart meter, LTCT smart meter, but the only thing is that this is more robust. It's more even in voltage fluctuation, because of our voltage issues, of our current issues also, it doesn't actually get burned easily. So these are very good meters. all right, the secure meters are very good. I told you that the first button is for resetting of the maximum demand, which is actually has to be done by an authorized personnel. And for doing that, normally we don't allow this. That's why we put this seal, so that nobody can reset this. But then if I am the authorized personnel, this is for testing purpose, you can easily do it. You can just take out the seal. Okay, I will take out the seal, and then I will try to I will reset this. We already saw that the maximum demand was 0.65 kW. all right, kW, and then I will see this. When I press this, what will it show? We'll go to the maximum demand portion. Where is it? We'll go to this is the present demand. all right, 2.97, and then we'll go to this is also the present demand in 2.97 kVA, and this is the September kWh of last month, and this is the this is the demand. Okay, maximum demand. If I keep pressing this, the maximum will reset. Okay, now it has got resetted. The maximum demand has been resetted. all right, has been resetted. By pressing this, you have to keep pressing continuously for 3 or 5 seconds like that, then it will automatically reset, right? You don't have a maximum demand now. All right, so that's why the first button is always used. You have to go to the maximum demand and keep pressing this continuously for 5 seconds, then the maximum demand, not 5 seconds, 3 or 4 seconds, then the maximum demand will automatically reset. Okay, so this is what you do. It has to be done by an authorized personnel. Whenever you go for reading, then he reset, so that he'll know the maximum demand of the preceding months on the coming months, all right, when you come next time for reading. So this is how the collection or the taking of the required readings is done for this secure meter. All right, so thank you.